For this lesson, we will begin exponential functions. An exponential function can be described by the equation y equals a to the power x, where a is greater than 0. Today's lesson, we will not be going into details on exponential function, but I'd like to review exponents because this leads into exponential function. Exponents essentially is the exponent of a number, says how many times to use the number in a multiplication. But their names when we write the exponents. The base refers to the number that we have that we want to multiply by itself. And the exponent tells me how many times I can multiply the number. So a to the power 2 refers to an exponent with base of 8, exponent of 2. So this means 8 times itself. 8 times 8 is 22. Exponents are also called powers or indices, as can be seen from this graphic here. 5 to the power 3 means 5 times itself, 3 times give me 125, etc. So we go down to 9 to the power 6, which means 9 times itself, 6 times. In general, a to the n tells you to multiply a by itself. So there are n number of those a's. A to the power n means a times a times a, n times. Some keyboard, because of the way it's designed, use symbol to indicate exponent. For negative exponents, it's dividing. A to the negative 1 means 1 divided by 8. 5 to the negative 3 means 1 divided by 5 to the power 3. And we can simplify it. In general, a to the power negative n is 1 to a to the power n. Let's look at the laws of exponents for review, and this is from your previous coursework. Here are the laws of exponents. X to the power 1 will be the value x. So for example, we have 6 to the power 1 is 6. X to the power 0 is 1. For example, 7 to the power 0 is equal to 1. The general rule is anything to the power 0 except 0 is 1. On positive integers, we have x to the negative 1. It's a reciprocal 1 over x, so 4 negative 1. When we have multiplying, the bases are the same. These has to be the same. The exponents are different. We add the exponents. X to the power 3 times x to the power 2 gives me x to the power 5. Now, this is a division, x to the power n over x to the power n. So m over n is x to the m minus n. We're subtracting when we're dividing. When we have a bracket, we multiply. When we have two different bases to the power n, we separate the bases by using the n for both. For example, y to the power 3 means x to the power 3 times y to the power 3. Now, x divided by y to the power n refers to, you can say x to the power n, y to the power n. And here is the reciprocal. X to the power negative n is 1 over x to the power n. When we have fractional exponent, the denominator becomes the root. For example, if you have x to 2/3 becomes the cube root of x to the power 2. And you can use a bracket to indicate the same. Here are some other examples. X to the power 2, x to the power 3, we add the exponents. Following our exponential rule here. Okay. Now let's look at some examples. Where we use exponents. And here we ask to identify the coefficient, base, exponents, and power. The coefficient is the integer before the variable. So the coefficient the base, if we go back to our exponent, this is our base, but in this case, our base includes the variable x. Oh. And our exponent, 4. Now, this could be rewritten as -1 x to the power 5. So this becomes the coefficient base and exponent is 5. Coefficient 1. This is x exponent -3. This 2 times itself 3 times gives me 8. To the power 4, 3 to the power 4 gives me 16. 1, 3 to the power 36, 1 over power 12. Now replace x with 3 and y with 2. So we have 3 times 2 to the power 3 minus 3 times 8 minus 9, 24 minus 9, 15. -3, 1 to the power 2 plus 1 times negative 2 to the power of 5, negative 3 plus negative 32, negative 35. To simplify each expression, this becomes x to the power 6, y negative 10, x because of the negative exponent, y negative 4 plus 2, y negative 2. What do I take to give me to the power 3? Give me 125, that'll be 5, because 5 times itself 3 times. So 5 by itself 3 times gives me 125. Or 2 to the power of 6 gives me 64. Here we have 0.5. Now we multiply these two, so we have 2 times negative 6, it's 3. So 0.5, which is 1 over 0.5 to the power of 6. Use our calculator, and this works out to be 64. This becomes 2 to the power 3, 3 to the power 3. It comes out to 2 to the power negative 9. Use your calculator, this simplifies to 38.44. And the final example becomes 8 to the power 3 plus 7 to the power 3. Now we add exponent, gives me 9 plus 7 over 3. We're going to be x16 over 3. Okay. Our next lesson will begin sketching exponential graphs.